Hello everybody, and we're in our final supplemental video for chapter 2, and this is going to be section 2.8. And a lot of the work that we're going to do here in working with inequalities is going to be very similar to the kind of work that we've done with equations. There are a few things that kind of separate this type of work from the other work that we've learned. So I'm going to introduce those ideas in the first part of this lesson here, and then use that new knowledge to carry out actually doing the questions here. So I'm going to take that information here and show it on this paper, and we'll talk about that. So one thing we want to talk about is the direction of an inequality. And I think most people can probably wrap their head around the idea that if we take that this symbol here for an inequality stands for less than, that this symbol here stands for greater than, if we write it with a line underneath, this will be less than or equal to, I should introduce this first, and if we turn it around to include the greater than symbol with a line underneath, we would then call this greater than or equal to. Okay, so just to get the symbology out of the way, we'll talk about how this plays with the math here in a moment. So let me kind of separate that work then from the first concept I'd like to discuss. So if I were to compare the number 1 with the number 8, I think most people would agree that if we have 1 and 8 and we compare the two, most people would say that 1 is going to be less than the value of 8. So let's say, for example, we wanted to look at this from the other perspective. We can go ahead and turn this around, and looking at it upside down, if we were to compare 8 to 1, if we can say that 1 is less than 8, we can say that 8 is greater than 1. Now, why is this important? Because when we start looking at solutions for the value of an unknown variable, sometimes we are required to turn those solutions around. So let's say, for example, I have a solution where we obtain the value. Let me move this up here. Let's say I have x is greater than 5. We could turn that around to say that 5, my apologies for that, where 5 is going to be less than x. Or let's say I have the solution here that 7 is going to be greater than or equal to p. I can turn this around, and I can instead say that p is going to be less than or equal to 7. So anytime I turn this around, if I want to flip a statement around for whatever reason, I need to flip the direction of an inequality. So that's one thing that we're going to talk about today when we start looking at solutions here. So that is the first part we're going to discuss. The second thing we're going to discuss is dividing by or multiplying or dividing by a negative. And we want to take a look at what happens in a problem involving an inequality symbol where we have to multiply or divide by a negative. So let's just compare this numerically what happens. So if we were to compare negative 1 and positive 3, I think most people would agree that negative 1 is going to be less than positive 3. However, if we take both sides and divide it by a negative 1, the resulting numbers would be, well, negative 1 divided by negative 1 is going to be positive 1. A positive 3 divided by a negative 1, that's going to be negative 3. Well, the relationship between 1 and negative 3 is 1 being positive is absolutely going to be greater than negative 3. So we can't simply just bring the less than symbol down. We're going to go ahead and have to make this into a greater than symbol. So now we have the relationship 1 is greater than negative 3. So the rule is when we multiply or divide by a negative number, we have to switch the direction of the inequality. What that may look like in a couple of questions is I may have a problem that reads negative x is less than 3. So if I want to get x by itself so it's not negative x, I may divide by negative 1. And if I do that here, that's going to give me x here, that's going to give me negative 3 here, and now that less than symbol is going to become a greater than symbol. If, let's say in this example here, I've got 10 is going to be greater than or equal to negative 2a, and I want to solve for the value of a, I would go ahead and divide both sides by a negative 2. This on, well, let's see, 10 divided by negative 2 will give me negative 5. Negative 2 divided by negative 2 will just give me a, but because I'm dividing both sides by negative 2, I need to take that greater than symbol, greater than or equal to, and now make it less than or equal to, giving me this result of negative 5 being less than or equal to a. We could even take this a step further using the first principle we learned about. If we wanted to put the variable on the left, we could switch the a, we could switch the negative 5, and then say we could say, instead of saying negative 5 is less than or equal to a, we could say that a is greater than or equal to negative 5, thus requiring us to flip the inequality yet again. So we'll talk about how this is going to be used here in a moment. So that's the second property we talk about in working with inequalities. Third property we're going to talk about is how we write the solution of inequalities. So, writing solutions to inequalities. And forgive me, but the bell is probably going to go off soon, so if you hear that, just bear with it. So let's say we have a problem that we work out, and we obtain the solution that b is going to be less than 4. So that's going to be one type of solution we're going to look at. Then we're going to look at another problem where we're going to say that c is greater than or equal to negative 2. So we're going to take a look at how these solutions can be represented in a few different ways. When you're doing the calculation work, you may obtain these as solutions, and this may be the form of the solution that could be asked for. But, however, there are plenty of numbers that are less than 4. 3 is less than 4, 2 is less than 4, 0 is less than 4, negative 10 is less than 4. So there's a lot of numbers. So this is kind of an algebraic way of showing this. Another way you could show the solution to these is what we call a number line. And what I'm going to do on this number line is I'm not going to put a ton of numbers down, but I'm going to go ahead and I'm going to show what 0 looks like. And for this I'm going to use a different color pen to put this out. And yes, a lot of noises around here. But I think we'll end the noise here for a bit. So we have 0 here. This is the number line. We have b is less than 4. So first what we want to do is we're going to want to mark 4 on a number line. So we want to know what that is. In the case if we have either less than or greater than, we're going to use parentheses to kind of denote where that's going to be on the number line with respect to that. So if I have b is less than 4, I'm going to use a parenthesis to show that where that is at 4. So we'll talk about how that's placed in a minute. What I'm going to do first is since I know that the values like 3, 2, 1, 0, -1, all these are less than 4, I'm going to use this as an arrowhead to draw an arrow from 4 to map out the solution of this. So I'm going to draw an arrow like this. And what that is showing is any number that is less than 4 is going to be a solution. Now, how do I show that it's less than 4 and only less than 4, like not less than or equal? This is where I'm going to put this here, and I'm going to just draw a parenthesis like this. I'm going to draw the other one in a moment here, and then we can kind of compare the two. Let's say I want to come up with a solution and graph the solution C is greater than or equal to -2. What I do again is I'm going to draw another number line. I'm going to go ahead and put 0 on that number line. And for this one, I'm going to go ahead and put the value of -2. From -2 again, I'm going to use the inequality as an arrowhead to tell me which way the arrow is going to go here, because I want to find all the solutions that are greater than or equal to -2, and that one is going to be like so. Now, we mentioned before that if we have less than or greater than, we're going to use parentheses. If we have less than or equal to, or we have greater than or equal to, we're not going to use a parenthesis. For this, we're going to use a bracket. So instead of using the parenthesis I have here, I'm going to use a bracket going this way, so that the bracket falls right on the line for -2. And the difference we're saying here is that -2 can be a solution for this. Like -2 will make this true. Here, 4 is not less than 4. It just kind of gets really close but doesn't quite touch 4. So that's why we use a parenthesis here, because it's only less than 4. Here, on the other hand, this is where it's going to be like greater than or equal to 4, which is why we have a hard line on, not greater than or equal to -2, which is why we have a hard line here. Okay? Now that's how we represent an answer using a number line. There's a third form for giving the answer to this, and this form is called interval notation. And the one nice thing about interval notation is that you can create interval notation in a very clean way just by looking at the answer we have with respect to the graph above. So what this is going to involve is, either having sets of parentheses, or maybe a parenthesis and a bracket, or a bracket and a parenthesis, or sometimes just two brackets together. It's going to look something like that based on what we're seeing up here. For the solution, we have b is less than 4. So where is this arrow going to? So this arrow doesn't stop. It keeps going all the way to -infinity. So we want to indicate that by kind of, let's see, going here. We want to indicate it's going to -infinity by putting that here, comma, and how far does it go? Where does it start from? It starts from 4. And here I'm going to put a parenthesis because I have a parenthesis on this. So see how like the -infinity to 4 falls right under that. So this is what we characterize as being interval notation. If we take a look at the other example here, we see this goes from like -2 all the way to +infinity. And what we'll do is we'll go ahead and just put this down first. So we have a bracket here because of this. The bracket comes from this being there. Here we don't have a bracket because we don't have the equal line being here. So I'm going to put a bracket here. Where does the bracket begin? At -2. Where does this go? It goes all the way to +infinity. And one thing to note about infinity is that with infinity, you will always have parentheses here. So this is one type of solution, just writing it out kind of algebraically. Another type of solution is a number line. Another type of solution, or a third type of solution, is interval notation. So we're going to use all the facts that we've just talked about here, and we're going to incorporate that and embed that into the work that we're going to be doing in the next set of problems we have coming for section 2.8. Okay. And these are taken right from the homework, so if you're looking for assistance on homework in this section, this should be of help. I will in fact be going over these questions in class too, but let's see how this works out now. Okay, so here we're giving a solution in interval notation, and we're asking to see what the graph of this looks like. So what I would encourage you to do, just to kind of compare, is let's map this interval notation above each of these. So let's go ahead and put an 8 to infinity here. We're going to put 8 to infinity here. We're going to put 8 to infinity here. And then we're going to put 8 to infinity here. Okay. So if you're taking a look at this, you'll notice that the map of 8 to infinity, we're putting the 8 like right over the 8. So infinity is going this way. The arrow is going in the opposite direction. So B is not a good choice. Same issue here. We have 8 going to infinity. This is going to a negative infinity. This is not a good choice. So it seems like the 8 to infinity seems to fall over these two nicely. The question is, which one is correct? Because it gives us a bracket, not a parenthesis. So we have to see which one of these choices has a bracket. Well, this looks more like a parenthesis, so that's probably not our choice. This choice actually here is going to be 8 with a parenthesis going to infinity. And this one, since it has a bracket and fits over quite nicely, C is going to be the correct choice for this problem here. Okay, so hopefully that makes sense for people. We're going to apply this same technique for the next few problems and see how we do this here. Okay, so let's go ahead and take a look at number 2. So we're going to go ahead and take this interval notation and put it over all these 4 examples, which you're not going to be able to do on the computer, but hopefully the visual here will begin to make sense. And you can kind of see that in your head mentally. Oops. So I'm putting this answer in interval notation over each of the number lines. And since this is going to negative infinity, how do we center this? We always put the negative, like number in there, on the number. This is negative 1, here's negative 1. Negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. So if you're looking at this, you can see like this doesn't map over the line at all. Same with this. So we're down to A and B. What are the choices between? A parenthesis or a parenthesis and a bracket. These must be the same. And since these are not, that leaves us with choice A being the solution to the problem in number 2. Okay. Let's go ahead down to number 3. It says graph the inequality on a number line, then write the solution in interval notation. So we want to have x is less than or equal to negative 3. So first off, what are a few things we should be looking for in this? If it's going to be less than or equal to, we need to be looking for a bracket. So with the less than or equal to, we should be looking for something that contains a bracket. So if it doesn't contain a bracket, we should be able to look at A and B and know that those are automatically out. The other thing we want to look for, because the arrowhead is pointing to the left, we want a solution that from negative 3 is going to be going toward the left. So here we have a value at, oh, look at this. This one's going at 3 and then going to the right. That's going the wrong direction entirely. This is the only one that has a value at negative 3 with the arrowhead going to the left. So this is the correct choice. Now, if we're going to try to put this in interval notation, what we're going to do here is we're going to go ahead and put that bracket, just like we have here. It's at negative 3. And where is it going toward? It's going toward negative infinity. And again, remember, with negative infinity, we always put a parenthesis. And that's going to be the solution for question 3. Okay. Question, let's see. Now question 4 seems to be showing up okay. So let's go ahead and take a look at that now. So now we have y is greater than or equal to 12. So what do we want? Because of the greater than or equal to, there are two things. One, we're definitely going to want some type of bracket. I'm not sure which way the bracket's going to go yet. We also want some arrow from 12 going this way. Well, they all seem to start at 12. Only 2 of them have arrows going to the right, and that's choice A and B. Since these arrows are going to the left, that's opposite the direction of the inequality. So we're going to cross out C, and we're going to cross out D. Now, we see 12 here. we have to choose which one has a bracket and which one has a parenthesis. And because of it being greater than or equal to, we want the one with a bracket, again, giving us choice A for the answer. All right, let's take a look at this, as this is going to become just a little more complex. And I might start putting some work onto extra paper just to show some of the complexity of this. Here in this question asks us to solve the inequality and then to graph solution set and write an interval notation. So we have negative 3x is less than or equal to 9. If you'd like to try to stop the video and see if you can get the correct answer to this, please go ahead and do so. Otherwise, I will just continue going forward. All right, so what I'm going to do now is I need to divide by negative 3. And hopefully you recall the little trick I showed you earlier, that when we divide by a negative number, well, this is going to give me x. This is going to give me negative 3. But because we divide by a negative number, we need to switch the direction of the inequality to make this x is greater than or equal to negative 3. So again, when we're looking for a solution to this, we want to first have an arrow that's going this way, and we also want a bracket. So only the first two choices have arrows going this way. And since we need a solution that contains a bracket because of the equal under the greater than symbol, it's going to be choice B. How do I write this in a notation? Again, I'm going to use this as a map. And I'm going to start this here, bracket in the same direction, going at negative 3. And where's it going toward? Positive infinity. And again, writing that with a parenthesis. So the final answer here is going to be negative 3, positive infinity. And that's going to be the answer to question 5. Looking at question 6 now, we have somewhat of a more complex type equation that we need to solve here. So let's see what we can do with this. So I'm going to bring a piece of paper in here to kind of show all the work and not worry about what choices we have, but let's just work this through. So the problem reads, negative 8x plus 4 is greater than or equal to 4 times 6 minus x. All right, so we have some real algebra going on here, much like we did when we were solving equations. But we're not solving equations this time. This time it's inequalities. So what we're going to do here is, first we're going to distribute to work our way through the parentheses. That'll give me negative 8x plus 4 is greater than or equal to, and that's going to be 24 minus 4x. From this point, if you want to do the same thing that I've been showing you with solving equations, you're absolutely free to do so. So what I'm going to do is I'm going to move the negative 4x here and make it positive 4x, and I'm going to move the 4 over here to make it negative 4. So I'm going to write this as negative 8x plus 4x is greater than or equal to 24 minus 4. So all I did was to switch this here and this here to the opposite sides and then changing their signs. So when I combine like terms now, I'm going to get negative 4x is greater than or equal to 24 minus 4, which is equal to 20. Once I do this, we're going to have to divide by negative 4. So if we divide by negative 4, we'll get x, we'll get negative 5, but because we're dividing by a negative, I now need to switch the direction of the inequality. So instead of being greater than or equal to, it's now going to read as less or equal to. So let's take a look again how we build that map given the solution we have before we look at our problem and see if this makes sense. So if I want to map this out, I'm going to go ahead and draw a number line. I'm going to put 0 on the number line. And I always want to put 0 so I kind of know where negative 5 falls in the scheme of things. And I'm going to put negative 5 here. From negative 5, the direction of the inequality is going to tell me which way I need to draw my arrow. Here, it's going to tell me, because I have an equal sign, whether I'm going to put a parenthesis or I'm going to put a bracket. Because it's less than or equal to, I put the bracket. And that's going to be how my solution is written. Now, that is in graphing on a number line. How does interval notation get written? Even more nicely. Because here we have the solution on a number line. So here's my bracket this way. Here's my bracket this way. negative 5. And what direction is this going toward? Negative infinity, again with a parenthesis. So if you understand how all that work was done, let's go ahead and take a look at the solutions we have on the paper here. So if you compare your work with a solution, we know anything with a parenthesis, that's not going to work. We know something that's going in the wrong direction, that's not going to work. This does in fact start at negative 5 with a parenthesis, so it's going to be choice D. And what's the solution in interval notation? Negative infinity to negative 5 with a bracket. So that is question 6, worked out and completed. Let's go ahead and take a look at question 7. It says to solve the inequality, graph it, and show the solution in interval notation. I think I'm going to go ahead and skip this one because I did. No, let me go ahead and do this one. But I just need a separate piece of paper to work this on. All right, so let me go ahead and write out the problem again and make sure that everyone can see this. So this is going to be a times 4x minus 1 is less than or equal to 4 times 2x minus 8. So this is going to work out to be 32x minus 8 is less than or equal to 8x minus 32. So I distribute on both sides, I get that. I'm going to go and move things around again. So I'm going to move this, make it positive, and move this and make it negative. So it's going to be 32x minus 8x is less than or equal to negative 32 plus 8. 32 minus 8, that's going to be 24x. That's going to be less than or equal to negative 24. Now, if we divide both sides by 24, we're going to get x here, we're going to get negative 1 here. Now, one thing to be cautious about here, we are dividing a negative, but we're not dividing by a negative. We're dividing by a positive 24. So because we're dividing by a positive 24, the direction of the inequality is not going to change. So that direction of the inequality is going to remain the same, giving us x is less than or equal to negative 1. So we're going to go ahead and put that solution on a number line. I'm going to go ahead and start with 0. I'm going to put negative 1 here. I'm going to draw, according to this, I draw the arrow to the left. And because it's an equal sign, I put a bracket going this way. That's a solution on a number line. If I want to take this a step further now, and I want to put this in interval notation, I'm going to use the graph to help me with that. So I'm going to put my bracket here, put negative 1 here. Well, where's this going? It's going toward negative infinity. And there's going to be my solution using interval notation. So now that you have this here, we'll see if you can fit kind of the whole thing in one page. Kind of hard to do. Well, you can kind of capture that there. You can see how things are worked out. Let's take a look at the work associated with problem number 7. It looks like based on our work, that final solution is going to be choice D. These zeros are going in the wrong direction, and this one has a parenthesis instead of a bracket. So, and after that, we have our solution interval notation of negative infinity to negative 1. And that's going to be our solution to that question. Let's go ahead and take a look now at question 8. This problem is a little more work, quite a bit of algebra to it. So let's see what we can do with this. So the problem reads 3 times x plus 5 minus 7 is greater than negative 6 times x minus 5 plus 14. So if you're tackling a question like this, probably isn't a bad idea to chunk your work into the smaller pieces. And let's do the distribution first. So the distribution is going to be here. The distribution is going to be here. And this is going to give me 3x plus 15 minus 7 is less than negative 6x, negative 6 times negative 5 plus 30 Watch out for that, and that'll bring down plus 14. So there's a lot of things that we can move around here. I can move these numbers to the other side. I can move this over here. So what am I moving? I'm moving 1, 2, and 3. So I'm going to have here 3x plus 6x. I'm going to have 30 plus 14 minus 15 plus 7. So 3x plus 6x is 9x. 30 plus 14 is 44. 44 minus 15 is 29. 29 plus 7 is 36. So if I have 9x is greater than 36, I divide both sides by 9. I'm going to get x is going to be greater than 4. Now that's going to be my solution, kind of an algebraic solution. Again, if we want to graph this on the number line, if you want to try graphing this on the number line yourself, feel free to stop the video in doing so. I'm going to put 0 here. I'll put 4 here now. Now, because 4 should be to the right of 0. The arrow, or the inequality symbol, tells me that I'm going to draw my solution going to the right. And here, because there's no equal sign under the greater than symbol, this is where I'm going to use a parenthesis. Okay, so finally have an arrow going to the right and using a parenthesis. And now if you want to take this a step further, we're going to go ahead and write the solution in interval notation, going with the 4, open parenthesis, 4, and where is this going toward? Positive infinity. So there is going to be our solution in interval notation. Now let's return to the problem and see what we have. So we want to find something going to the right. These are going to the left. So that doesn't work. These both go to the right, but we need something with a parenthesis. C has a bracket. We don't need it. So B is going to be the correct choice. And the answer in interval notation is going to be 4 to infinity. Let's go ahead and take a look at question 9 now and see what we have for that. It says graph the inequality. Okay, so what you notice here is that x is between two things. So, and we want to take a look here at how this kind of works. So we're saying that x is between -4 and 4, which you have going on in A and C. Here, you know, we can't go past -4. Here we can't go past +4. These two don't work. What we're kind of saying is that -4 is less than x, which is less than 4. So which of these is more appropriate? The difference between this graph and this graph is between the brackets or the parentheses. And if you want to pause a second to take a guess which one's the best one, you can. Assuming that you're keeping going, because these are just less than, this is going to be the brackets, therefore giving us C as a choice for this. If we write this in interval notation, what we would do with this is we would take this graph and we would go here and here, and this would be -4 to 4. So the solution for this is going to be -4 to 4. Okay. Let's go to number 10. It says to graph the inequality here. So some things you want to look for. You want to see everything is between 3 and 6. 3 and 6. 3 and 6. 3 and 6. What are they assessing? When to use a parenthesis or when to use a bracket. In the case between, like for 3, because of the equal sign, a bracket's going to be here. In the case of 6, because it's only less than, it's going to be a parenthesis here. Two parentheses don't work. A bracket, parenthesis, that looks right. Parenthesis, no. Parenthesis, yes. Parenthesis, bracket, no. Bracket, parenthesis, no. Parenthesis, bracket, no. So it looks like choice B is going to be the correct choice for this one. Okay. So, and if you were to write this in interval notation, this would be like here, watch this. Let me write it above actually. Bracket, 3, and then 6, parenthesis. So we take the same things we include on the number line, put them here, and we have our solution in interval notation. All right, let's go and take a look at number 11 now and see how a question like this is done. So we refer to this. This is what is known as a compound inequality. is like two inequalities kind of sandwiched together in the same question. Okay, so we have here 3 is less than or equal to 4x minus 13, which is less than or equal to 7. Now, the trick I showed you before doesn't exactly work with this one. We're going to have to stick with more traditional ways of doing math here. So what I want to try to do is to get this middle part here to be just x. So what I'm going to do is I'm going to go ahead and I'm going to add 13 here. If I add 13 to this part, I have to add 13 to this part, I have to add 13 to this part. So that's going to give me 16 is less than or equal to 4x, which, and this is going to cross out, which is less than or equal to 20. So I've got this. Well, I have 4x here, so I'm going to divide this by 4, I'm going to divide this by 4, and I'm going to divide this by 4. And once I have that done, that's going to yield the solution. 4 is less than or equal to x, which is less than or equal to 5. So I have 4 is less than or equal to x, which is less than or equal to 5. What is this going to look like on a number line? Here's 0, here's 4, and here's 5. So less than or equal, it's between these two. So it's going to look like this. So we're saying x is between 4 and 5, and that's exactly what's going on. Okay. In interval notation, you can map it out very elegantly here. And there's your final answer written in interval notation, just right under the solution of the number line. So let's take a look at the choices we have here. And it appears we did this correctly. Choice B is going to be the correct choice for this. Yeah. We have a few word problems associated with this now that we're going to go ahead and take a look at. And that should complete your homework help to help you with this. And yes, if you've noticed, this is going to be a longer than normal video, but hopefully you find it helpful. It says 2 more than twice a number is less than negative 14. So if we know, so when you want to look at this, look for the word is. And usually we talked about the word is being equal. But if we see anything like greater than or less than or something like this immediately following it, we know we are talking about an inequality. So that phrase is less than is kind of the breaking point for how we write this out. So I'm going to go ahead and put this here, and I'm going to just include this here, and then I'm going to break it up into 2 parts now. So the first part of this is what's negative 14? I'm going to go ahead and write that out. Negative 14. 2 more than twice a number. So 2 more than twice a number. Twice is 2 times, as I've indicated in other videos. 2 more than twice 2 times a number, x. So we can say 2 plus 2x is less than negative 14. And that is how we write that out. I'm not going to solve this here. I'm just putting these together because I've given enough examples of how to solve it, but I think this is going to be the greatest obstacle for students to work through. Next one. Okay. Mark and Heather Starr are celebrating the 25th anniversary by having a reception at a local reception hall. They have budgeted $4,000 for their reception. If the reception hall charges $80 cleanup plus a $36 per person, find the greatest number of people that they may invite and still stay within their budget. So what we're looking at here, like this per person, so $80 is like you pay 1 fee for that. 36 per person. Per is another word for multiplication. We don't know how many people they want, but we want to figure out what the greatest number of people is. So what we're going to do here, if they have $4,000, okay, they can't spend more than $4,000. So whatever they spend, it has to be less than or equal to $4,000. So what are they going to spend? They're going to spend $80 per cleanup plus $36 for each person. And that is the equation necessary to be able to solve that, or inequality, I should say, to be able to solve that question successfully. Okay. And it says round down to the nearest whole person as needed. Okay. Let's go to the next problem, 14. Ben bowled 153 and 184 in his first two games. What must he bowl in his third game to have an average of at least 180? Okay, so let's take a look at this. Now this one is a little tricky, ladies and gentlemen. This question can take a little time to understand. Now, let's say, for example, you have 3 tests, you want to find the average. So to find an average, let's just talk about this question a second, or just another question more generally. If you find the average of 3 items, you would, let's say, take the first item plus the second item plus the third item. You would take that sum and then you would divide by 3. And that would give you the average. Okay? So what are we being asked to do? We're being asked to take the sum of 3 things divided by 3, and its sum has to be at least 180. So what does it mean at least? Are we talking about greater than 180 or less than 180? If we're talking at least, then let's say if you want at least a 90 in class to get an A, that means you want a 90 or greater than 90 to get at least a 90 in class. So the way at least translates to is going to be greater than or equal to, because at least would include that. So when we hear the word at least, that's going to be greater than or equal to. So whatever these 3 things add up to be, when we divide them by 3 to get the average, it should be greater than or equal to 180. So the first 2 scores are going to be 153, this is going to be 184, and then we have this x here. Okay, so let's see how we carry out, let's see how I carry out the mathematics of this now. Let me put this up a little bit so you can kind of see that. So we have 153 plus 184. Let's see, my quick math tells me 337. So we have 337 plus x divided by 3 is going to be greater or equal to 180. I've got that here. So what am I going to do to get clear out the fraction? I'm going to go and multiply everything by 3 over 1. Well, if I do that, here in this first part, the 3's cancel, just giving me 337 plus x is going to be greater than or equal to 3 times 180, which is going to be 540. Yeah, I want to say that's correct. Okay, there you go. Now you have 337 plus x is greater than or equal to 540. So if I write this out, x is going to be greater than or equal to 540 minus 337. And that's going to give me x is going to be greater than or equal to 540 minus 337. I want to say that's going to be 203, but I'm going to double check my work since I'm on video. So, oops, 540 minus 337. Yep, and that's going to be 203. So if you want an average of at least 180, that means you better get a score of at least 203, which means 203 or greater. And that's going to be the answer to question 14. Yeah. Let's go ahead and take a look at the last question, 15. I'll show the work there. 3 times the number increased by 1 is between negative 11 and 7. Okay, so it's between negative 11 and 7. So let's take a look at what the is means now. So to say it's between there, so there it is. Okay, 3 times the negative number increased by 1 is between negative 11 and 7. Okay, so I'm going to just check my answer here real quick to be absolutely certain I'm expressing this the proper way. Yeah, so it's between there. So 3 times the number increased by 1. So 3 times a number increased by 1. 3 times the number increased by 1. So it's going to be 3x plus 1. And that's going to give me the expression that I need here. And then they want us, they actually, for this one, just want the inequality or compound inequality using the variable and then find them. So here's the second chance of doing a compound inequality. So I'm going to subtract 1, subtract 1, subtract 1. I'm doing this to all parts because it's like a double equation or a double inequality almost. Why they call it a compound inequality. -1, -11 minus 1, that's going to give me -12 is less than 3x is less than 6. And then finally, if I divide by 3, divide by 3, divide by 3, -12 divided by 3 is going to be -4x 2, giving me the solution of -4 is less than x, which is less than 2. I hope this video helped you out, and I'll be going over a number of these in class, but I figure it couldn't hurt to have some extra examples to look by. Thank you.